Rightio, welcome back. Part two. Blood alcohol. Yes. Josephine measures her mass to be 50 kilos on a Saturday night. She had 4 standard drinks in 2.5 hours. Form of blow shows to estimate the blood alcohol content for females, where N is the number of standard drinks, H is the number of hours, and M is the person's weight in kilos. So again, when you see these questions, you're not going to be asked to remember the formula. It's not on your formula sheet. It'll be given to you. Show that, oh, look, here we go. Again, look at this lovely little thing. Show. So look, because guess what? We are telling you the answer. Do not fudge it. Okay. And how would I show this? It's a 1 mark question. All they really want you to see is to put the right thing in the right spot, really. So let's do it. So we'll say VAC is equal to 10 times. Now, N is number of drinks, isn't it? Yep. Number of drinks times 4 minus 7.5. And H is the number of hours multiplied by 2.5 hours all over 5.5 times, and their mass is 50. And that should equal 0.08. And if I had that question, I would probably just get my calculator out and make sure that, hey, I did indeed get that answer, which I need to get. So 10 times 4 minus 7.5 times 2.5 all over 5.5 times 50, and then rounded to 1 decimal place. I can see, yes, I've got it. Yay. All right. The formula given above can use the term number of hours a person reach. The formula above can be used to determine the number of hours required after a person starts consuming alcohol for the BAC to reach 0. How many hours? So again, it's going to be a substitution. So time is equal to 0.08 over 0.015. And then use our calculator again. So we've got 0.08 over 0.015. Okay, so I'll put that into that. How many hours? So this is equal to the time, 5 hours and 20 minutes. Very good. Question 6. So here we go. First of my multiple choice. Our high school has 130 students in each year group from year 7 to year 12. A survey can be conducted to determine the number of hours studied per week by students. Which of the following would provide the most representative sample or survey? Okay, it's not going to be a stratified one. Stratified one, because of the 100. Sorry, I have to pause. I think my daughter just got home. Okay, sorry. It's been actually a couple of hours since I paused this. I think I must have been talking about stratified sample, and I'm sure this is going to sound really weird when you watch it. So I do apologise. I might go back and fix it later, but at the moment, it's 9:30 on a Tuesday night, and no, I'm not going to fix it right now. So I said stratified samples. Stratified samples talking about when you have a different different amount of students in each year, or different amounts of people you're surveying, and you want to get an even representation. So like a good example at our school would be, there's more year 7s than year 12s. So if I was doing a survey of 100 people, I couldn't pick the same amount from each year group. I'd have to pick a percentage higher in the year 7 versus year 12 to get a stratified sample. Census, there wouldn't be census because census you'd have to survey every single student. The other two, which of the following would provide the most representative sample for the survey? For me, I'd have to go systematic. The only reason I'd say systematic over random is you could end up with more students in one year than another. A system might be you might select, let's say, from a year group, you might select every third person, or you might select every fifth person in each year group, whatever it happens to be. So that's what a system is. Random is just literally random. Like literally go around, close your eyes, and pick a whole bunch of people. So you might end up with a whole range of different people. But at least if you have a system like you could line every student up and pick every fifth person or something like that, whatever. So yes, I'd have to go systematic. Good old GST. This one always gets fun. Train trip costs $6.80 including GST. Is the train trip's price before GST? Correct, the nearest 10 cents. Okay, so this one, the easiest way to do it is $6.80 or 6.8. I'm going to divide it by 11, and you can say, why 11? What is 110? Because GST is 10%, and the cost of your item is 100, so 100 plus 10% is 110%. I'm going to divide it by 11 because 110 divided by 11 is 10. And then once you've divided this number by 11, that gives you the GST component of what you are doing. And then we're going to multiply it by 10 because we had 10%. And then it should be $6.18. And just to show the point, what a lot of students, and I dare say the answer will be probably B, if I just did $6.80 times, I'm going to say 0.9 as in 90%. And $6.12. Oh, close. Okay. All right. So yeah, when you find out what's the train trip before GST, so that's where we got that one from. Very nice. How are we going with time? We should have a fair bit of time up our sleeve. And we do. How many questions got to go? Oh, that's it. Wow. Okay. Percentage. What's percentage error? Okay, percentage error. It even says, and sometimes they don't even put the percent sign in. Okay, so what you're looking for is the smallest unit. Okay, the smallest unit possible to measure in this case is 1 centimeter. Even though it says 3, I'm just talking, they've used some sort of ruler, or measuring device where they're going up in centimeters, okay? 1 centimeter, 2 centimeters, you get the idea. Okay, had it been, had it said 173.4, for argument's sake, then I'll say the error, or no, it's not the error. It is called on the formula sheet. Limit of reading, I think it's called. The limit of reading is what we want. The limit of reading in this case is 0.1. If that was in centimeters, it'd be 0.1 centimeters. Okay, so we're just looking for the smallest unit. In this case, we've got 1. And so what you do with your limit of reading is you take it and you divide it by 2, and it's always 2. So 1 divided by 2 is equal to 0.5. And we're going to say plus and minus. And what that's saying is, hey, this could have been whatever you're measuring. His height could have been anywhere between 173.5 centimeters and 172.5. So there is a bit of measurement whenever someone's looking at this. The percentage error, though, so this here is our absolute error. Okay, our percentage error is our absolute error divided by our whatever we're measuring. So in this case, we're going to say 0.5 over 173. That's not a dot, by the way. That was just me being sloppy there with my writing. Times 100 because we want as a percentage. And they're usually really small. Most of these ones are usually small. So I dare say it's going to be probably C or D, I think. So 0.5 divided by 175. Okay. Oh, no. And now you can, if you look at it here, you can see why C's in there. And it's actually going to be, the answer is going to be B. I should have. Reason why this is not going to be C, this is not a percentage yet. It's not multiplied by 100. So you've got to remember, put in the multiplied by 100. Okay, it goes out the window what I said just before about being small. Okay, and there you go. So the answer is B. Now, I hope that's helped. Sorry about the massive delay. And I'm sure when someone listens to this and goes, what the hell just happened? When I was filming the original part, my wife and my daughter walked in the door, and I had to do all the family stuff, and so it's been like 5 hours in between. So I do apologise. I might come back and fix it, but it might be funny to listen to later on anyway. All right, I hope that's helpful. I'll talk to you guys soon. Bye.